How does radiation with no charge become ionizing, like photons and neutrons? It's a fun question. And with photons, it can be a little bit intuitive when you remember that the photon is an electromagnetic field. So it's got an oscillating magnetic field, an oscillating electric field, and so that magnetic field can interact with the electron and jiggle it, and the electric field can actually push the electron when it interacts. And so it's an electromagnetic effect with a photon so that it can scatter off of an electron and send a reeling through Compton scatter. Or you can actually cause absorption through a quantum effect where the electron just literally absorbs the energy of the photon, and residual energy that's left over is converted into kinetic energy and sends it sailing off. That's actually what Einstein won the Nobel Prize for, is figuring out the photoelectric effect. But then you can also, with the electron, create antimatter. If it's a really high energy photon, you can start to create some antimatter. Now, hopefully it's more obvious, say, with electrons and alphas and charged particles, how those would interact with electrons and knock into them and sending them off, making the atom that was left behind ionized, and hence getting the term ionizing radiation. Neutrons are a little more fun. How does a neutron cause ionization? It's primarily through interaction with the protons. And there, it's primarily through interaction with water, through the hydrogen and water. And the reason why is because neutrons and protons, they basically have the same mass. To within a fraction of a percent, they're the same mass. And so they interact like billiard balls, a neutron with a proton. So that on average, when neutrons are interacting with protons, they'll give up half their energy. So a 2 MeV neutron, high energy neutron, coming into something with water in it, when it interacts with a proton, on average, it will create a 1 MeV neutron. And a 1 MeV proton comes off in an elastic scatter. And so that process, that 1 MeV proton, that proton is now ionizing. It will strip off electrons as it travels through a material, and so it's ionizing. And then that 1 MeV neutron that went off, that can go off again and create a half an MeV proton. Now, it can transfer all of its energy in a single scatter, but on average, it's only about half. Now, neutrons can also do similar things with larger nuclei, but you're not going to get as much ionization out of it. It'd be kind of like those billiard balls whacking into a bowling ball. You're not going to get a large recoil of a bowling ball if the billiard ball reflects off of it, because the billiard ball it's almost going to be like elastic. The billiard ball will come off with about the same amount of kinetic energy as it went in, and the bowling ball will have some recoil. So the dominant form of energy deposition with neutrons is going to be with protons, but really high energy neutrons can do more. They can actually cause spallation, where if you have a high enough energy neutron, you can split up nuclei, but now we're talking many, many tens of mega electron volts. So you don't even get neutrons of that energy from a nuclear reactor. You've got to basically go to a very high-powered linear accelerator or cosmic rays or something like that. So I hope that explains it. How do you get ionization from neutral ionizing radiation fields? So I hope you all enjoyed that, learned something, and you have a fantastic day. Thanks for watching.